and we just change one thing, something like this. So like we have a two area. One is expecting a rectangle type, I mean a struct, and another one is circle one. Now we do not get any error, like we are reflecting rectangle, which is something like this, and on that we are calling our area. Okay, and we have not done anything here. We can do like r dot hmm, oh sorry, that needs to be like that, r dot width plus r dot height, like that. The circle is, I think, area of the circle is 2 pi r square or what? It's a very pi r square. Oh, sorry. So we can, is we get 3.14 into uh, c dot radius into c dot radius. Sorry for that. Yeah, so there's a math dot pi. We can take that one, math dot pi. And then we can just take it, the check we like how we do for the last function with the helper. We can do again with these helper here. I'm writing an helper here. Sorry, I just eat some pani puri and then come back again. That function takes that t, then testing tv, and then it takes shape, which shape it is. So that shape is needs to be saved. Do not have that shape right now. We will add that shape. Just a minute. T dot helper got shape dot area. Okay, then it will be having interface, right? Yeah, something like this, I guess. Type shape interface and then take a area like that. And I think it also returns some of the things. Load 62. It's not taking anything. It's not taking anything, but it is a returning float 64. It in that way. Okay. If got this is not equals to on, then we will return this. So this is an important one. T dot helper. And then you just have to call the rectangle. We don't need got. We want only, and want one is we already know about it. What want is, what other things are. So we just take these whole things till this point and then just delete it. So rectangle is taking a rectangle and then this, and then just we can, yeah, in the same way. Okay. Uh, it's good to have this here maybe at the top. Okay, we can do format. Okay, so here you can see read wait what. This is a quite different in interface in most other programming language. Normally you have write code to say my type 4 implements interface bar. In our case, rectangle has a method called area that returns float 64, so it satisfies the tie shape interface. Circle has a method called area that returns float 64, so it satisfies the shape interface. String does not have such a method, so it does not satisfy the interface. So in Go, the interface resolution is implicit if the type you pass in a match is in matches what the interface is asking, it will compile. Okay. Okay, let's do decoupling. Notice how our helper does not need to certain itself with whether the shape is a rectangle or circle or right or triangle. By declaring an interface, the helper is decoupled from the concrete types, and only has the method it needs to do its job. Sorry. This kind of approach of using interface to declare only what you need is very important in software design, and it will cover it in a more detail in later section. That's right. Further further refactoring. Now that you have some okay, so now you have some understanding of struct, we can introduce table driven test. What is this? TDT. Table driven tests are useful when you want to build a list of test cases that can be tested in same manner. Okay, that is good. We can do this one, and then we sorry, oh, sorry again. Here we can say a table driven test. This is the first time I was hearing a table driven test area TDT. Okay, it is a TDT. Takes T, that is a testing. Sorry. So it is having something like area test, which takes a struct and then a shape, one float 64. And then rectangle is this one, which is a 12 6, which returns 60 72, and then 10 has this value. Okay, so we are taking an area test which is in a strings having shape. So shape is first one, and then wand is our okay. Bit of confusing, but yeah, we can um, do it. So area test is taking a struct, an array of struct, sorry, struct, which taking a shape, sorry, shape as a shape and one as a float 64, and then this one, and then it calls rectangle because it taking a shape. Okay, and then that shape is 12 6, and if I type sorry, it expecting a parameter here or something, some other way you can say 60 float 64. And if you do a struct, if you hover on a struct. It does not give you this one, it give you this one. Okay, so you can take this as a 72.0. You need this, and it works. Yeah, it works. Now if you want for a circle, you take circle which takes 10, which is the radius, and then you take this much value, put it here, put a comma, that's good. And then for tt, that takes a range, which is an area test, and that area test will take got as tt dot want, sorry, take dot save dot area. This is the point where we are taking what we got, and then we are checking that got is equal or not by from the want. And if it is not, the we return t dot errorf. This is what we got, and what this is what we want. Sorry, a lot of what a lot of got. Okay. The only new syntax here is creating an anonymous struct area test. We are declaring a slice of a struct by using struct with a two field, the shape and the want. Then we fill the slice with cases. We then iterate over them just like we do any other slice using the struct fields to run our tests. You can see how it could be very easy for a developer to introduce a new shape, implement area, and then add it to the test cases. In addition, if a bug is found with the area, it is very easy to add a new test case to exercise it before fixing it. Table test driven can be great itself in your toolbox, but be sure that you have a need for extra noise in the test. They are a great fit when you wish to test various implementation of an interface, or if the data being passed into a function has a lot of different requirement that need testing. Let's demonstrate all this by adding another shapes and testing it. A rectangle. Okay, you can also add rectangle one or some other. Mhm. I don't think so. We need a rectangle one because we will add one more rectangle and then just take it 1 by 2 into like base into height. You can refactor trace driven development by example. There was a very good book. We can look at this book. Okay, I'm just putting this test driven. You have access. Get a PDF. I think we have access. Okay, make sure your test output. Oh, we get it, bro. We will read it after some time. Uh, it's just taking a. I can't purchase every book. I just purchased this one. Designing data. A lot of folks. Yeah, I will be following Ben video. So Ben and sorry,
Stuff
don't
is like
get
media
me.
assets that aren't
Okay, Ben or Martin videos both, and then I will be coding some of the things by learning from both both Lee's and uh, Martin and Ben. I can say Ben is can consider him at least, and Ben is also really good at teaching things. He works at a Planet Scale, one of my favorite company. So you can see a lot of videos are okay. Oh, there was a Sears in that. Hmm. Okay. Is there anything IBM 1000 share price 25? Oh, so this is a chapter one where is a multi currency money, and then we are writing this. We will follow this, but I don't know will I be covering this one or not. But yeah, on some of the day I will head up to this book and will try to cover it. Uh, well, it could be a good learning. I think it could be very good learning curve for me to go through it. Okay, but it will like take a lot of time. Exactly, it will take a lot of time. We can set up this one, but I don't know will it I cover it all or not. But yeah, I can say maybe because reading that much can cause a thought problem in to me. But yeah, it's good. This one is a good, I guess. Those are no any chapter or things like that. We have a part one, which is a money example. So we can cover money one in a 1 week, and then in the next week we can cover X unit example, and then we can cover test driven development. The money example is not test, I think, or is that test? I don't know. Is that test or no? It's not test. Like we already have a lot of three uh, go mistakes type. Oh yeah, go 100 mistake. That one will be I will be covering this one. I will be doing this whole thing live, but a lot. I tried it some of a problem here and find out very noob, and I am a noob. I know. And the another one is effective go. This one is a really absolutely important for me to get better at Golang is effective go. This one I have to cover it mostly, but my focus for now is just to cover this one what I am reading, and then I will cover some of the topics like let me just give you some of the topics like concurrency, and here I just put some of the things uh, like this one concurrency in very depth, not testing the context in very depth. These are context, mutex, and API development. CLI, I have a lot of experience around CLI, building a CLI, as I am also building one of the CLI around. Okay. I'm covering this one to complete it, and then I will take a 5 minute break because I have a coffee with me. I can't take it because if I take a coffee, then my avatar will will uh, complain me. So Max, remember earlier when we are implementing rectangle, we are failing. It printed this one got 0 1 36. We knew this was in a relation to rectangle because we are just walking with it. If that bug slipped into the system in one of the 20 cases on the tables, how could a developer know which type case failed? This is not a great experience for a developers. They will have to manually look through the cases to find out which case already failed. We can change our error message into something like this one to this and this. So the percentage v could be the format strings will print the struct. Okay, that's cool. Struct with a values in the field, so the developer can see at a glance the properties that are being tested. Okay, that is cool. I can add that one. Not has a area. I don't have a has area. What was the previous one? Has area. If a rectangle have a area, then we can say I can do this 6. I just run it. You can say, oh, sorry, I'm really sorry. I mean, this one needs to be here. And I deleted this that one. Now we have a struct.circle radius this got this one but won't. Okay. So we wrapping it. There was a declaring interface parametric polymorphism. Yeah, we know parametric polymorphism. So we will starting this one, and there was a lot of more thing. You can see a lot of things. I don't know. Will I cover it today or not? But it is very. I can say. I can cover it till concurrency. I think. Let's see. I'm closing it for a 5 minute. My author, my And the other one is effective one. This one is a really, really absolutely important one. By direct line is effective. This one. I have to cover it. So, I focus just this one. And I will cover some of the topics, some of the topics like what currency, and just put some things. Uh, this one, concurrency context, context. These are context, mutex, and API development. CLI, I have a lot of experience around CLI building. I'm also building one of CLI around. I'm covering this one to complete, and then I will take a 5 minute break because I have a coffee. I can't take it because if I take a coffee, I so makes remember earlier when we had implemented, right, we had failing implemented this one called 0136. We knew this one because we had we just got slipped into the system. But 20 phases of it's how to detect the now. This is not a great experience for the developers. They were like just to find out which case already but cannot आई थिंक बेन का मुझे वीडियो देखना चाहिए बेन का वीडियो से पता चलेगा बहुत ज़्यादा Let's let's go start about friends at the friend. So the property can see at a glance the properties that are being tested. As a area, I don't have an X area. It's the yeah, so we are back again. There's a point. There's a pointers. So we already learned around struct pointer struct go, and then we also need uh pointers struct go. Again, we can add an extension by writing a pointers. It can also add a pointers underscore test.go. Yeah, that could be quite good fun. At some point, you may wish to use a struct to manage state and exposing methods to let the user change the state in a way that you can control. Fintech loves Go and Bitcoin. So that amazing banking systems we can make. Let's make a wallet struct which lets us deposit Bitcoin. Okay. Yeah, there will be I mean a 3-day session for um, for the schema first development in Golang. Yeah, schema first development in Golang. Oh, sorry. Okay. So we can add a function which have a test wallet. So like we need a wallet type, and then there needs to be have a deposit function, and it also have a function balance. Okay. Okay, let me just write it first test, and then I will write the function, like the core function. If you do this, then testing would be good to go. So we need a wallet which takes a wallet type struct. Yeah, that's struct. Wallet dot have a deposit function which takes 10. It is something like a bank function. It's not like we just giving it a way of Bitcoin. But yeah, like they love Go. One equals to, we take a 10 and then just take it this one. And okay, so we need wallet. Mhm. We need wallet with the interface, I think. So we also need a deposit, which I think does not return anything. The balance, which balance return Route 64, and it takes integer, I think, x as an integer, right? And mhm. So if we call balance, it will return a balance function. And if we call deposit, there will be some amount. On that amount, we will be having our something like, I can say, like amount, and we will just deposit, and so we can get that one. So this one is a wallet. Okay, so we want something other. You can say wallet interface, something like that. Okay, we can just close it for now. I think we can go with that one, like uh wallet. Okay, let us go with these one first, and then I will try to do it with the interface one. We take a wallet, and then that will be a deposit, and that deposit is amount. This takes integer. You will be having some balance, right? Because we have a balance, and that balance will be a, amount. Sorry, amount. And balance is going to be take a wallet. We will take a wallet and then balance, and that balance will return integer. I think I said float. Maybe some taxes, some GST, something like that. Yeah, but we want a simple. We want simple, right? We want simple. There's till this point we have not used anything around like got 0 but 110. Why? Why we balance added amount 10 but we are not getting that? Why? But if you print here, you will get that. But if you're returning here or and testing it, you got a error like got 0, 110. That's quite right. Well, this is a confusing. Our code look like it works, right? Yeah, it works. We add the new amount onto our account, onto our balance, I mean, and then the balance method should return the current state of it. So we need to remember one thing in Golang, when we call a function or a method, the argument are copied. You remember one thing when we do somewhere this one, when we did this one in the last one, we copy one thing. If we are copying these things and if we are changing anything on that copy one, then it will be add to the copy one. But here's it was a reference to x, and here we are changing the y, which is a referencing directly to the x, then x also changed. So we want something like that, not the copied one. Something like we directly reference to that address and then we change that value so it will be reflect to all places. So when we are calling this function deposit, the w, that's w, is a copy of whatever we want the method. We want to give it as a reference. What we want, we need to give it as a reference without getting too computer sciencey. When you create a value like a wallet, it is stored somewhere in a memory. You find out what the address of that bit by ampersand my value. If you do ampersand that value, you will get that. Yeah, yeah, you can print out this one. If you want to do this one, you can do that. If you run this, where the address of the balance in test is this. So if you go to this address and if you change the value to that place, you will get that value. But let us take a look at where is we have a pointer here, and then sorry, you can close this whole thing and then be here. So the address of the balance in deposit, this, and then so I can check the address is somewhere else like 2D0 and here 2C8. Both addresses different. When both have a difference, then how if you are changing that value, so that value is somewhere else, right? So the percentage p placeholder prints memory address in a base 64 notations with leading 0x, and the escape characters prints new line. And if you see that if you want we get the pointer memory address of something by placing an ampersand character at the beginning of the symbol. And if you rerun that, you will find something like that. In my case, that's different. In their case, something different. So how we can fix that? Like we getting a different two addresses. So when we change the value of the balance inside the code, we are working on a copy of what comes from the test. Therefore, the balance in the test is unchanged. We want pointer. Pointer let us point to some value and then let us change them. So whether taking a copy of that whole wallet and then we are changing that point somewhere else, we take pointer to the wallet and then we change that original value. So nothing much in that. You just add asterisk. If you add asterisk, and if you, the difference is the receive rather than this one. So here if you like, if we run this, will it work? Yeah, it works. So the difference is the receiver types is this one rather than this, which means you can read as a pointer to the wallet, sorry. Try and rerun, you will pass. Now you keep wonder why did they pass, why they didn't dereference the pointer in the function, like so, like this one. Yeah, I think maybe, like, I was thinking something like we need to pass it through somehow, like that one, like we will be passing somewhere in this one. And yeah, this one also can be catch to me, like why we are not passing in that way. Like, you might wonders why did they pass, we did not dereference the pointer in the function, like so. Okay. And symmetrically addressed the object directly. In fact, the code above using this, that is a pointer to W, is absolutely valid. However, the maker of a Go demeaned this notation. So the language permits us to write this without explicit dereference. This pointer to struct even have their own name struct pointer and they are automatically dereference. Okay, let us look at some of the things. Automatically dereference. Okay, we can read it better. Not time to refactor things. Technically, you do not need to change balance to use a pointer receiver, as taking a copy of the reference is fine. However, the convention you should keep your method receiver type the same for consistency. Refactor, we are making a Bitcoin wallet, but we are not mentioning them so far. We are using int because they are a good type for counting things. Yeah, and it seems I struct uh, a bit overkill to create a struct for this, and integer is a fine in terms of a way it works, but it's not descriptive. Mhm. You can take a Bitcoin as an integer, and that does not make any sense. Like we just take the yeah. Oh, okay. To make Bitcoin, you just use the syntax Bitcoin 99, which gives you an integer. Yeah. By doing this, we are making a new type and we can declare methods on them. This can be very useful when you Want to add some domain specific functionality on a top of exiting types. Let's implement uh, a stringer on Bitcoin. So the type is stringer, interface is string. Okay, it takes a string. Okay, let us do it. Otherwise, we will miss a lot of more things. Oh, we, we need a pointer here. Okay, what we did, we take wallet, then deposit. We deposited 10 bitcoins, and then we check a balance, this one, and then we want a 10 bitcoin there. And 10 bitcoin. 10 bitcoins price. Oh my god. That's crazy. Okay, so we are creating one type of a stringer, and then takes an interface which takes a string as a method and which returns a string. Okay, and then you can just take a function, and that function is okay. That's b is an integer, and take on a string, and that strings will return a string. And that one is a fmt.sprintf. Mhm. As you can see, the syntax for creating a methods on a type declaration is a way as its struct. So we are taking a deposit. We deposited their 10 bitcoins. We got this balance, and then we got this one. I don't see any. We don't have a withdraw. Withdraw is it? Like till this point, we don't have a withdraw. Yeah, we need now withdraw. So we can take a wallet and then withdraw, and then amount is already it needs to be Bitcoin, right? And then this balance is like, but we want some of a function because this is not right. Yeah, this is not right. Reason maybe we are poor. We don't have in that much Bitcoin. How can we withdraw then? Withdraw insufficient funds. So if you do insufficient fund, let's take Bitcoin 100. Okay, why it's not wallet withdraw, no value, used as a value. Mm-hmm. You need error because that's not expecting any uh thing to be returned. This one now it fixed. Okay, yeah, we are like expecting some error here, but it is not returning anything. But here, if you have, if your amount is a greater than what you have, then we need to return an error. That is a simple thing. I mean, if I have only 10 rupees or a $10, how can I withdraw 15? That does not make sense. Yeah, now you can refactor it. The test side, you can assert a error, and it can take it as an helper function, and you can use that one. If there was any error, then you can say assert error, or maybe assert balance, like that. Mhm. Yeah, you can do that too. Like this one is a really good to take it a more efficient, because you can search it, and you can use it uh, a lot of places. I mean, in different functions, you can take it and use it like that. Yeah, like that. Taking a copy of this, we are printing it here and then explaining you. So we added on a assort balance. Assort balance takes wallet and want, and then we take a t dot helper, which like that we give a wallet first, and after taking that wallet, you can see that we are having a wallet, and then we are sending a bitcoins that balance. You're checking a balance, and then the error is like you can error and then error efficient. So here, if you got equals to null, or if it is around somewhere else, like it is not expected to what we got it and what we are expecting, then we can return error. Mhm. Here we are using assert no error. Okay, withdraw with the funds. Okay, so we added a 20 and then we returning a 10. This is a want. We need a want. So we just put 20 and then we are returning 10. So in this function, we don't want any error. Okay. Pointer can be nil. We can read it. The pointer go copies values when you pass them to function slash method. So if you are writing a function that needs to mutate the state, you will need it to take a pointer to the things you want to change. The fact that Go takes a copy of values is useful a lot of the time, but Sometimes you wouldn't want your system to make a copy of something, in which cases you need to pass a reference. Example include re-referencing very large data structure or things where only one instance is necessary, like database connection pool. Mhm. Okay, we're doing this all things. A nil, a pointer can be nil. A function returns a pointer to something. You need to make sure check if it is a nil or might raise a runtime exception. The pointer wouldn't help you there here. Useful for when you want to describe a value that could be missing. Mhm. It was a good one. So error are the way to signify failure when calling a function slash method. By listening to our test, we conclude that checking for a string in an error could result in a flaky test. So we refactor our implementation to use meaningful value. Instead of this resulted in easier to test code and conclude this could be easier for users to our API too. This is not the end of the story with error handling. You can do more sophisticated things, but it's just an intro. Create a new types from existing one useful for adding a domain specific meaning to values can let you implement interface. Pointer and error are big part of writing Go that you need to get comfortable with. Thankful the compiler will usually help you out if you do something. Just take your time and read the error. Okay. The last one we get interface, right? Yeah. Mhm. Can let you implement interface. So in interface, what I did till this point, we takes on a wallet interface. That wallet interface expecting on a balance of this. Okay. Uh, if you take the struct one, we take the shape there. Mhm. And on the shape, we call area. Hmm. On the shape, we call area. And you can see on the shape, we have a rectangle, we have a wall, circle. So how can we change that? I mean, uh, uh, I was not getting that point. Like, how can, like, I know this thing, but uh, something like, just let me take a help. Can you help me to implement interface? Yeah. Yes, you're very close already. Your wallet already implemented interface. You just haven't used that interface. So we have that. I implemented that, and then you take why wallet implement it. Okay, this wouldn't work. This works. Yeah, this works. So use the interface. So we can go to our test. We can go to the test, and we can change the wallet to wallet interface. Yeah, that's correct. And that wallet interface will take that, and then we just have to pass it as a ampersand. What I said you earlier, then like we need something like this one. One thing more, because I left that, is this one. Okay, so now we are using that, right? We are using that. That's cool. Can you give some other simple example and how it works to get better understanding? Yeah, yeah. So we are taking one more example around interface. So you can say we have a shape of area and we have a square. We already take this one, I guess. We have a side, and then we want area in this, and then type also we want area, and then we want to print like that. So why it works, the same interface requires area. They do not expect like keep I mean which struct we are it, but it only expect it needs to be area. Yeah. So if you do that whole thing, it will work. Another example is notifier interface, your wallet's style type example. So we have a notifier which takes a send function and then a type email. You can also do SMS for the SMS one. So this is an struct. We take that email and then we take the SMS and we take that message. Okay, that's also cool. So notifier all and email, SMS, and some others. Okay, that's cool. Here we will read this. It is something like, okay, so we have a map, we have a dependency injection, and a lot of things. Okay, map is really interesting, and we need to get better at map too. Uh, so you need all code of this chapter. Oh, sorry. uh, in array and slice, you saw how to store values in order. You now we need to look at way to store items by key and look them up quickly. Okay, maps allow you to store items in a manner similar to dictionary. You can think of like keys as a word and the values as the definition. And what better way is there to learn about maps than to build your own dictionary? First, assuming we already have some words with their definition in the dictionary, if we search for a word, it could return the definition of it. Yeah, like Rahul, what's the meaning of Rahul? It will return the meaning of Rahul is this. Again, we will be having test first and then we will write the code function after that. Okay. Test search testing.t and then we say dictionary, which takes a map of a string and a string. It will also return a string. We can take test and then we can say hello Rahul. X of we can go for Rahul. X of Rahul. Okay. Oh, sorry. What we got is we have a search which take dictionary and then a key that is Rahul, and we want this one. Sorry again. I call a lot. Sorry, to be honest. And then this one. So we need to implement test search. So declaring a map is somewhat similar to array, uh, ex except it starts with a map keywords and requires two types. The first is the key type, which is written inside the bracket. The second is the value type, which goes right after the brackets. The key type is special. It can only be comparable type because without the ability to tell if two keys are equal, we have no way to ensure that we are getting the correct value. Comparable types are explained in the depth in the language spec. The value types, on the other hand, can be any type you want. It can even be any other map. Everything else in this test should be familiar. Uh-huh. Try to run. Then we take dictionary as a map, a string, and a string, and then word. The word is like a key. You can take it as a key. And function, we take a search dictionary, which takes map, string, and a string, and you can take a key, which is also a string or a key, keyword, whatever you want. And you will just return. So it will, like, if you return this, and here also need to string. If you go here and then run it, it failed. Yeah, want this, we get this. Got this and want something else. You can see. Okay, so you can go take it in a assert a string if you want to. Like you can put this whole thing, remove this. You can do in that. So no, if it have that one, if we have a function and then t dot run, in that way we can. So you can say assert error or a string, assert a string, and then t is a string dot tb, and then we got and want, which is a string. Both are a string. T dot helper, you can t dot helper and then just print it. That is what you want. And then so the string t got one, like that. Yeah, so here if you see this map, we are taking as a map, a string and a string, but this one looks very good. I mean, this is a way to write it, so you can remove this and you can come up here, type this struct, which is, I think it is a map of a string. Sorry, not a struct, I mean, I was thinking it's struct. Sorry, map of a string of a string. Okay, that looks cool. We also remove that. Then we can go with something like function d and the dictionary, and then you can call it search a word or a key, whatever you call. Mm, that's a string, and then also strings, and then just return percentage d. But we do not have uh, anything here. Mm. Like we created a dictionary first, which takes this one, and then known keyword and unknown keyword, like that. Now you can call it like this dictionary, sorry, dict dot string. Then that Rahul needs not to be there. You need to be Rahul, like that. Let me call it. Let's see. Yeah, this works. You can just return this assert strings. Okay, so this is a assert strings. Oh, sorry. The dictionary dot search. We expecting two values? What do you mean by that? What happened? I didn't see the test. Assignment mismatch two variable, but dictionary dot type returns one variable. Oh, okay. The another one is error. Uh, okay. Assignment two match, and this will be error. If that value does not return anything, so here you can just take this and you can say a definition, and you can say okay. So this will be d dot key, and if it is not okay, you need to return I mean, you need to, sorry, okay, that looks good. You can refactor it. You can take that error not found into the error.new. We already did that. And you can just add a unknown keyword like that. And then you can also call assert function like how we did in the last one. And you can run now, it will pass. So add one is like you want on a dictionary into the dictionary to add one test. This is just a test. This is just a test like that. Mhm. I mean, in that, uh, I mean, if you see here, dictionary dot, we don't have add. Mhm. So we need now an add function which take you can say like that. You can take that one. I think here's also it returns add or maybe not. No, it will not return anything because if it is present, if it is not present, it will add it. If it is not it, if it is present, then it will what it can do, it will return it. Hmm. So you can take d dot word and dictionary definition. It also takes a definition and a one keyword word or keyword. I can say again word and definition. Definition. Oh, what's that? Okay, that definition. Okay, again we come up there. That same problem we got earlier, that copy one. Yeah, I was thinking like if we are directly pointing to then an error, array or a map of a string, there will be a problem because we are not referencing that thing. Then it will be having a copy of that. That the same thing happened when I was giving one uh, interview, and I wrote the code in that similar way, like how I have currently. And that makes like in the last I fixed a bit of a problems there. But if you see the pointer copies at all, an interesting property of the map is that you can modify them without passing an address to it, like this one. This may make them feel a reference type, but the Gav we describe, okay, we will be reading that too. They are not. A map value is a pointer to runtimes dot has map structure. So we can pass a map to a function methods. You are indeed copying it, but just the pointer part, not the underlying data structure that contain the data. A gotcha with a map is that they can be null, nil value, and a nil map behave like an empty map when reading, but attempt to write to nil map will cause a runtime panic. We know about it. You can read more about here. So we need something like that. We need this, but we won't make one. Yeah. Instead, you can analyze an empty map or use a make keyword to create a map for you. Mhm. We will need to first search it. If it is a error not found, then we will do such things. Firstly, I already said like we need to first search it, and if it is a present, then we don't have to add it. Like why we will be have add to. So if it's the switch, we can use switch error, and if error case is like error not found, then we can do the word, sorry, equals to definition. If it is not, then you can just return. And the default one is, I said earlier, like it will be error. Call it error. We are calling test, not we are not calling hello. We are adding just a hello. And remove that. We can add this one. Assert error, assert definition. We need assert error, and assert definition is here. We need assert error. Where is assert error, bro? Okay. New word test. Could not find a word that you're looking for. New word. Okay, so yeah, I think we have some error. Could not find, could not find the word you're looking for. I think, yeah. Is there anything wrong I did? I don't see any error. Mhm. We are the same. This is the same. Fail. Found package pen. Hmm. That is a returning true. I don't know. Oh, I can do update if you writing test and then add. Add one is like in that similar way I did in the yeah. So add is like you need to search, right? The logic is you need to search is that present or not. Yeah. Can refactor it and test. Update is like update word and then definition. In that similar way, you also need to first search it. Update in update. You need to first search it. If it is not found, then error does not exist. And if it is a found, then you can just take that word and then just update it. You can delete it also. Mhm. In delete, you can just delete that. Now, I think we first need to check is that word is exist or not. Firstly we search it, we find it out, like if not exist then it does not exist, and if it is exist, if nil, then we can delete it. So we create it, we search, we add, we update, and we delete it. I'm going to that code to the last version they have and just checking everything once. The seventh version definition. Yeah, so you can see, yeah, so we have an dictionary error which is also known as string. Okay, so we call something like this an error And then error returns in a string, which is in a string of error, whatever the error we give it to them. And then a type, which is a map string and a string. And then we call a search. That search takes word and returns word and error. Maybe in that way, we when we put the word, it's not that type. So error could not find the word you are looking for. Like that word does not present in the dictionary. We add that. We add that one. Sorry, we add that one. Like in add, how the logic needs to be. We need to first search, yeah, and then we check if it does not exist. Then we will directly add in that. If it does not exist, then we add it. If it exists, if it is exists, if it gives nil, means it exists. So error word exists. When error word exists, then we need to return that error that it exists. Mhm. And then default is like this, and then we the default if any other thing happens there, then update one, we also need to first search if is that word is present or not. If that word is present, if it is not present, we need to return an error. And then if it is present, oh yeah, if it's present, then we just need to update it, delete in the same way. Okay, that's cool. We get some of the things. If map isn't a reference variable, what it is, we will read that whole things. One more constant error. What is this? Go map in action. Mm-hmm. Cool. Yeah, this one we have seen that. This one we have seen that. This is a one other way. We have a node exploiting zero values. We takes a node where next and value that is a linked list. The first we reference to a node visited, we check make map of that, and then we take n, that is a first, we go to the till nil, and then we are going next again, right? It will be n dot next. If it is a visited, then we can say cycle detected. Yeah, it was like the circle one. Yeah, if we visit it, like we are changing that, managing that it is visited or not. So if it is a visited, we will true, and if that comes out to be visited, then we say yeah, fire cycle detected. And the person type, name and likes, we take on a people as a array of pointer to person. We likes in that way, we range to the people, and that we take range that p dot likes equals to that l is taking from that, and we are appending to that people. Mhm. That person likes that. Like you have cheese and the p dot name, like cheese. Hmm. Okay, I'm closing now. I'm bit getting throat problem. We already did near about 1 hour. 1 hour 36 minutes. I think those are three more topic. We want to go in map bit more. I will be covering that one too. Thinking to cover that one too. Hmm. That was in a string that cheese, then person. Yeah, that was an error. Array. Likes that L takes in a string and then appending that to P. That P is a portion. Hmm. Okay, that's cool. I'm closing for now for today. I will be going deep dependency injection, mocking, concurrency select, and this in night. But maybe I will be not live. Will not go for a live because it is like bit of uh, taking much time for me to go through it. I think I can practice these whole things offline to get it better at all the things at as quickly as possible because it is taking much time when I was doing live. Maybe that's why I will try to cover it first, and then we have a project called this one, footer. So if you see, let me show you. You can see this one. What it takes, it is an API slash version one scan. It takes an image and a registry, docker.io, and organization, myogs. And then an image ID is you like it's an just a random one. And we are now scanning that. Is that uh, like the CV, SBOM, and some of other things. You can see SBOM, vulnerability, and it's saved to the S3 bucket. If you do this, you can find out this whole SBOM and some of other things. Yeah, you can see vulnerability CVs like that, and you can also find out that whole things here. I have to change a lot of things in it, and I was thinking like there's a lot of um, AWS API we need. Let's see how things go. Okay, so we can now wrap up and bye bye. Oh, I was on the auto one. Okay, we can. I was like, yeah, so we can now wrap up.